Hey everybody, welcome back to Faraday Research. This is part 2 of my Don Smith generator. So in the last video, we were talking about etheric power versus inductive power. All right, so the etheric power, just as in the last video, I had this coil hooked up to the system, which draws in the radiant energy from the vacuum and redirects it through 2 spark gaps to light the bulb. That's a very efficient way to light this bulb. Now, we're dealing with etheric power, okay? So, like I said in the previous video, that you cannot measure this type of power. It's because all the videos and all the lectures that I've seen with Eric Dollard, he says when you're dealing with Tesla power, you cannot use like a voltmeter and an amp meter and expect to get the proper readings on it, because you're dealing with such a high frequency, and also because it's a disruptive discharge going through a spark gap. Now, because of that, the physics of how that operates is completely different. Etheric power, I would say, is your stage 1 type power. All right, stage 2 power is the induction type. That's the one that we use today to power our world, is through a Faraday core and an induction coil. Now, again, the physics also changes, because if you start pulling a load off at the secondary, it's going to draw more amperage off the primary. All right, and even though that I'm using disruptive discharge, it's going to pull, because of Lenz's law, it's going to pull current from the disruptive discharge. So I'm kind of mixing, two of them together. So I want to demonstrate in this video the disruptive discharge working with an induction coil. All right, and I could do a whole video on the coil and how everybody thinks it works. I think it's talking to each other through frequency, because the electromagnetic field that's induced in the coil is locked in this space here. How can it travel through a core to the other side to induce the current on this side? So it's up for debate on exactly how that works. There's a video where Dollard and Chris Carson did a video regarding how an induction coil actually works, or a transformer. Okay, so we'll kind of leave that one alone, but I just want to demonstrate how you can make an induction coil work with a disruptive discharge. All right, so right now I got about set at 11.5 volts. All right, and I was pulling about 11.5 watts. Now, when I turn it on, all right, it's actually a little bit less, believe it or not. It's because, actually, it's going up now. Yeah, so we're almost at 11 watts power. It was about 10 something, so it's actually pulling more watts. Okay, so you can see I'm still getting a very good result, but I'm using induction this time. I'm not using a disruptive discharge for the actual direct power to this bulb. It has to go through the induction transformer, and then from the transformer it comes to the bulb. So kind of mixing two different types of physics together. Now, if you want to carry on from here, now because this generator generates about 43 kilocycles, I got to get it down to 60 hertz if I wanted to run like an appliance like this. I have to get the frequency in check before I can hook up something like this to it. Otherwise, I would blow it up, or it won't even work. The other thing too is the amount of voltage is actually truly coming out of this. It has to be 120 volts at 60 hertz to run our appliances. So this is kind of this first stage of your power system. So from here, you have to change the frequency to 60 hertz, and then you got to regulate the power to 120 volts AC in order to run an appliance. Running light bulbs, that's different. You can get away with a high frequency and high voltage. So this is kind of the first step of that system. Now, You could go so many different ways with this, but I just, in this video, wanted to kind of demonstrate disruptive discharge running a transformer, okay? So you're kind of mixing the two, but now you're making it into a power source that we can start working with now. So more work has to be done with this power to change the frequency and regulate the voltage. If you can get it at 120 volts at 50 to 60 hertz, now you can run appliances, okay? But I'm just showing that, you're still getting power, but the more load you put on this transformer is going to relate to this. It's going to start pulling more amps, okay? So as soon as you can get it within the parameters of 120 volts at 60 hertz, now you can put a voltmeter up to it. Now you could put an amp meter up to it. But up to this part right now, you cannot. It doesn't work. So I don't know if this made any sense to anybody, but yeah, it confused me for a very, very long time. And I had to do a lot of digging to figure it out. If you haven't subscribed to the channel, bottom right hand corner, if you have any questions, comments, leave it below. And yeah, I also got my Bitcoin there. I got my PayPal donate and also my Patreon. I highly recommend becoming a Patreon. You'll get all my designs that are on paper. Any exclusive stuff I post in the Patreon that I don't post on YouTube. So yeah, you can get some more detailed information on this kind of stuff in my Patreon. So all the links are in the description. Give me a thumbs up if you like the video, and we'll see everybody soon.